Do what?
Yeah. That's not a bigger memory card. It's not a memory. Anyways. It's the camera. We looked into it so much. Alright, are we good?
Yep.
Okay, so today we have an awesome speaker lined up for you. It's the last week. I wouldn't put anybody in here that isn't extraordinary. But we have Jeremy Blum. He is of Blum Idea Labs and of MakerBot and of Cornell University and of Google X Labs and of a bunch of other stuff he's going to talk about. Anyways, he's a very prolific engineer. He is also into teaching. He taught BlueStamp's program last summer here in New York. So I encourage you to ask him all kinds of questions and see what else you can learn from him.
Cool. Thanks, Dave. Hey guys. Okay, so my name's Jeremy. As Dave just said, interrupt me at any point. But basically, what I'm going to do is I'll go through some of the stuff I've done to give you an idea of what I can actually reasonably answer questions about, and then we'll just chat because that's more interesting anyway than I am. Okay, so some background. I did my undergraduate and my master's degree in electrical engineering at Cornell University. I worked at MakerBot for 2 years. For those of you who aren't familiar with it, it's a consumer 3D printing company. It was just purchased by Stratasys for $400 million or something like that, or $40 million. A lot of money. I didn't get any of it, unfortunately. I just wrote a book called Exploring Arduino, which I'll pass around if you guys want to flip through it. How many in here are using Arduino for your project? Okay. So if at any point you Googled Arduino or questions about it, you've probably already read something I've written. Right now, I'm the CTO and co-founder. You can't see it all on here, but right now I'm the CTO and co-founder of a startup called Sun, based out of Manhattan. Basically we've invented energy-efficient light bulbs that emulate natural sunlight indoors to mediate your biological clock, reduce seasonal affective disorder, save energy, all kinds of good things like that. In a month, I'm moving out to San Francisco to join Google X, where I will be doing hardware design for Google Glass. Who here has heard of Google Glass? For those of you who haven't, it's a piece of wearable tech that's basically a computer on your face that overlays information over whatever you're doing. It's very cool, trust me. Okay. I'll go through some of the projects I've done. You probably are not going to be able to see any of them. Yeah, this is, all right. I'm just going to go to the video because it's easier. These are projects, but you can't see any of them, sorry. But there's a lot of them. Okay. Okay, I'll just do the video. And hopefully you'll see it a little bit.
Can we turn the lights off?
Yeah, that's a good idea.
There we go.
That's it. All right. This is a learning robot that teaches itself how to walk. This is a truss manipulation robot. This is just an example, but if you imagine something like the International Space Station, for example, that's constructed of various trusses connected together, you would deploy a robot like this on it, and it can make repairs, reassemble it, and move the trusses around in different locations autonomously. Kind of think of it like a mobile crane. So this was just this was just accepted for publication in a scientific journal a few weeks ago. This is a musical performance that we did with a glove controller I made. So this dancer is wearing a glove, and her motions are triggering the sound effects. So I've done a bunch of kind of art and technology integration projects. This is part of the same performance with some LED wands, again controlled by the music and the dancing, controls the lighting. And then here, a similar thing with the wands. And the music controls what color the wands are, and then there's a video streaming a kaleidoscope view of the wands that shows up on the screen, and then I'm controlling it with the glove. This is a mobile app for controlling the hat that I wore at my master's degree graduation. So this is a Raspberry Pi, which is a tiny Linux computer mounted on my wrist that connects to the internet, and then people in the audience could bring up the mobile app and control what color my hat was during graduation. So I had really bright LEDs on it. To give you an idea of how bright they were, any of the LEDs that you guys are using in your projects are probably about 20 milliamps, and I was using 16 350 milliamp LEDs, so it's like a spotlight shining out of the top of my head. The video doesn't do it justice because the white balance autocorrects for the imaging. But that was that. This was a 24-hour hack for a Facebook hackathon about a year ago, where basically we put Facebook inside of a book. So we hollowed out a book. It's very messy, obviously, because we only did it in 24 hours. But each of these screens show your Facebook newsfeed, and then you flip the cover to cycle through it like you would in a book. And then there's buttons for like liking statuses and things like that. That was a 24-hour thing. Yeah, so you can click on each of the buttons and it'll zoom into each of the screens and you can view the comments on them or press a button to like them, things like that. This is a 3D printed, partially 3D printed and partially not, smart sun tracking solar panel. So you would deploy this outside, figures out where you are in the world automatically, where the sun is, and follows the sun over the course of the day to get the maximum amount of sunlight. So it's a solar panel on top. These are some of the electronics underneath, which are actually the same electronics that are in the MakerBot 3D printer. Because it happens to be a controller. Let's get a photo of it. Computer output display that shows how much power you're generating. This is it moving over the course of a day. This thing in the back is a car winch hooked up to a motor with a 3D printed bracket and a bunch of duct tape. Your best, WD-40 and duct tape are your best friends. And this is it moving over the course of the day. As I said, I went to Cornell, which is in Ithaca, and it rains a lot, so the testing was actually done indoors because this was not waterproof. But it does work outside. So for those of you who have not seen a 3D printer, this is the one that I designed all the electronics for. This is the MakerBot replicator. It's printing out a life-size skull. So this is an actual CAT scan from a person. And it's printing out a copy of the skull out of plastic. So this is obviously sped up a lot. This is probably a 12-hour print. But I designed all the electronics for this. And that's what it looks like when it's done. This is another interactive art project that I'll kind of skip through because it's not super interesting. But it reacts to motion and sound. It makes noises too, but they're very annoying noises, so I took them out. This is the same glove that I was using in one of the musical performances earlier. Here I'm using it to drive a car. So just like a normal car, you kind of hold your hand out like this to turn it, and then you flex your finger to accelerate and decelerate. And you can clap to honk the horn and do kind of cheesy things like that. Another interactive art display thing. These are Christmas lights that react to music. And this is most of these things are all open source and on my website, and you can, all the source code and stuff is online, so you can make these. But I'll move forward. Right. So this is them actually going and responding to music. Here's a GPS tracker. So this is in Washington Square Park downtown. Sorry, it's a little bouncy, but I'm walking around the park, and then the location's being logged in real time and saved to a memory card, and then gets uploaded to Google Maps, and you can see where you've walked over the course of the day. Okay, so that's like a selection of maybe like 10% of the projects I've done. And all the rest of the ones, everything I've done is on my website, so you can go look at it. But so real quick, the projector started working again. Is it when I move my laptop?
It might be a loose connection.
So I'm an electrical engineer, as Dave mentioned. I don't just do electrical engineering. I kind of dabble in mechanical and biomedical and computer science and pretty much everything except chemical engineering, because I'm horrible at chemistry. But it's my job every day to make the world more awesome. It's very cool. So every day I wake up, I go to work, whether it's the startup I'm working for now, soon it'll be Google, or when I was teaching BlueStamp last summer, and I just get to go to work and do things that make the world more awesome. And so all of you are here. You're all obviously interested in engineering, I hope. Otherwise, you probably wouldn't be at BlueStamp. And so you guys kind of have the opportunity to do this too. These are the things that drive me to do what I do. I don't anticipate solving the world's problems in my lifetime because I don't think any one person can do it independently. But the things I think matter a lot, solving the world energy crisis in our lifetime, there's the possibility that global warming is going to completely decimate everything, which I think is pretty bad. So I obviously don't want to see that happening. So I do a lot of renewable energy research. You saw a solar panel, but I've also built solar-powered homes, designed energy control systems, things along those lines. Improving healthcare is a big one, obviously, as you all know. Making people's lives easier, just making the world a more interesting and awesome place to be in. That's kind of, I think, where 3D printing comes in a lot, and things like Google Glass. And teaching, I think, is really important because it's not really super helpful if I'm the only one who's working on these things. We need a critical mass of people, which is why all of you guys are in BlueStamp and learning these things, so you can help to make the world better. So I'm not going to talk much more about what I do because I'm more interested in talking to you guys. You can turn the lights back on. But in terms of stuff we can talk about, I'm happy to talk about college applications, happy to talk about any of the engineering projects I've worked on, advice in general, pretty much anything. I'm an open book. So let's chat. Let's questions. Yeah.
How difficult was it to design the paperback?
It was difficult. I definitely was not the only person working on the team. There was a team of on the first replicator, maybe 5 of us working between mechanics, electronics, and software. I definitely made a lot of mistakes along the way and learned a lot as I was doing it. And I went into it with a lot less knowledge than I came out of it with. So I learned a lot in the process, and I think in engineering in general, you can kind of go to school for something, but it's pretty meaningless until you're actually like in the field and you try to apply it, and that's where a lot of the actual learning happens. So yeah, it was hard, but I kind of learned a lot along the way. The internet is like your best friend for that. We're very fortunate to have that. And then just talking to people around me, the more senior engineers there, was incredibly helpful. Although when I did the initial electronics design, I was somewhat on my own because it was a small company at the time. It was about 20 people. Now it's like 300. But when I was there, I was basically the only electrical engineer. So I kind of had to make up a lot of it as I went. I screwed some things up, learned from it, made it better, and kind of iterated.
Can you talk about the on-the-foot car?
Yeah, sure. So that was initially a project for one of my classes sophomore year. Basically, the way it works is there's a glove that you wear, and the glove has gyroscopic sensors that detect rotational movement, and then flex sensors on the fingers that detect finger movement, vibration for detecting clapping. And then, so the original impetus for creating it was, this was in 2009, before there were a lot of kind of gesture controllers available on the market and before a lot of phones were really using it for anything. So the Microsoft Kinect wasn't out yet. Most phones weren't really using gyroscopic control for anything useful. And it was in a product design class, and we were thinking a lot about how if the computer was invented today, the mouse probably wouldn't be a thing. Like, the mouse is a very weird, arbitrary method for interacting with a computer. Touchscreens really make a lot more sense, as do gesture control in general. It's a lot more natural. So we wanted to try to approach that. It's capable of controlling a computer directly, but we thought an RC car would just be more fun for the kind of initial proof of concept. It's hypothetically capable of driving a real car, but I would never hook that up to my real car because I don't want to destroy it. The idea there was we just wanted to make something that was intuitive, like no learning curve sort of thing. So going like this to turn, kind of pulling on your hand to accelerate, we thought just kind of made sense. So I let a lot of other people try it on who had not designed it with me to see how they reacted to it and kind of get an understanding of how people interact with natural control interfaces. So that was kind of how that project went. And then so we did that, we got it working. And then I wanted to keep experimenting with it, and I'm like going a little off topic here, but one thing I strongly recommend that you guys consider doing is when you're in college, take a lot of classes that are out of your area of comfort. So I took a music class the following semester, and I'm like the world's worst musician, and just like really terrible. But I took it was an electronic music class, so I figured I'd at least have like a little bit of understanding. I was still pretty wrong, but I did take it, and one of the projects for the class was to put on these performances. And I was like, oh, I have this glove. It'd be like really easy to adapt it to do musical performance stuff, so I did that with it. It was nice because it let me expand on something I'd already been working on. It also meant I didn't directly have to like produce music in any meaningful way because it would be terrible. So it was kind of win-win. But I expanded on the project in that class, and I've continued to expand upon it after that. And it's all open source on my website, so actually a lot of other people afterwards have also written software for it that's not me, who have done considerably more interesting things than I did with it. One of the students, there's a student in Colorado who based a project off of it and used to control a life-size robotic arm. He ended up making the glove a lot more complex than what I had done even. And there's he has a photo online of the robotic arm shaking Obama's hand at the White House Science Fair. So I'm a little jealous of him. But that was pretty cool. And that was partially based on my code, so I feel like I kind of got to shake Obama's hand through the robot and like 3 degrees of separation. Yeah.
Are you allowed to talk about any of the work that you have been asked to do for the hardware for Google Glass?
Not really. Frankly, I don't really know what I'm doing yet. So for those who are not familiar, Google Glass is done in Google's X Lab, which is like their secret, like evil laboratory. It's not evil, secret research laboratory. They also do like the self-driving car there and things like that. So I don't really know anything that is not already publicly known, and even if I did, I couldn't tell you. But I don't really know anything yet. All I know is that I'll be doing hardware design for it, presumably working on the next iteration of the device, since there's already a version out there in the wild being tested. The improvements you can expect are exactly what the issues are now. It needs to have longer battery life. Longer battery life, more responsive. Just making the product better in general. I don't know exactly how my role will fit in there yet. I'm excited to see where it will go. I myself am totally skeptical of the concept of wearable computing, so I'm going into it skeptical, intentionally wanting to like prove myself wrong that it's actually amazing. I've tried Google Glass only once, and it was a tremendous amount of fun. It worked actually a lot better than I expected it to, so I'm already a lot more optimistic. But beyond that, I don't really know. Yeah.
Is it possible to play Angry Birds on Google Glass
Probably.
using the touchpad?
Yeah, probably. I don't know. I mean, that'll be on the programming interface is open for developers, so that'll be on who's the developer of Angry Birds? Rovio, is that right?
Yep.
Yeah. It'll be on Rovio to make the app compatible, but it's conceivably totally possible. And since there's a camera too, maybe it'll be augmented reality, and you'll be able to actually kind of like slingshot birds like at buildings that you're looking at, and it'll create some cool effects. Yeah.
I don't understand what Google Glass.
Sorry, yeah, I should probably explain that. My apologies. So Google Glass is this will be so much easier if I show you a video. I don't have internet in here. Okay. Google Glass is it's a pair of glasses. They look, like normal-ish glasses. There's a camera on them that's forward-facing, and there's a refractive glass display that sits over your eye. What that means is it basically overlays information transparently over what your field of view is. So if I'm like looking at a room of people like this, it doesn't do this yet, but maybe what it'll do is like, well, okay, so it's not allowed to do face detection for privacy reasons, but an easy example to explain how it might work is imagine I'm in a room looking at you giving a talk. Glass might overlay like little name tags above each of your heads so that I remember what all of your names are. And it's kind of like transparent over your field of vision. So it's not like you're just looking at a screen that's in the corner of your view. It's a transparent overlay. And because it's so close to your eye, the field of view is said to be the focal point is said to be at infinity, meaning that no matter where you're looking, there's always like an in-focus display of information over it. So you can imagine like walking down the street and navigation instructions actually like put arrows on the street saying like turn down that way. Or you can like give a voice command and say take a picture, and it'll take a picture of whatever you're presently looking at. Things like that.
That is nice.
Yeah.
You're gonna make like a pair for people who have glasses?
Yeah, so I wear glasses obviously, and I hate contact lenses. So my first order of business there is going to try to be to make sure that happens. They already have a partnership with Warby Parker, which is a glasses manufacturer, and you can already put in like shades into the glasses. So it's presumably a pretty short leap to put in prescription lenses. It shouldn't be hard. So I've asked them. It will be possible to wear them with glasses. And in a way that's not like putting two pairs of glasses on. Yeah.
Would it still work in like bad lighting?
It should. It's supposed to. Yeah. It should work in any lighting conditions. I would imagine it might be hard to see if you're like staring at the sun, but you probably shouldn't be staring at the sun.
Yeah, that's bad.
And in dark lighting conditions, it is backlit, so it should still work. Yeah.
It's gonna be cheaper.
Yeah. The price will come down.
How much?
I don't know. Right now they're $1,500.
What?
So yeah, they're a little out of most people's price ranges. But it's it's still a very early developer version. They're still working out the kinks. I'm sure they'll go down.
Like 300.
I couldn't say because I have no idea.
That's pretty
If you look at the there's like you can Google online for a teardown of the electronics. They basically crammed an entire cell phone into a pair of glasses. They're not they're complicated pieces of hardware. So it's not surprising that they're expensive, but I'm sure it'll come down. Yeah.
Oh yeah. Speaking of like cell phones, do they have any plans with different carriers yet?
Does Google?
Yeah.
Well, the way the glasses work now is they have Wi-Fi in them and they tether to your phone. So you need to like have a phone in your pocket for them to. Well, you can use them without a phone. They can talk right to the internet through Wi-Fi, or they tether through Bluetooth and Wi-Fi to your phone. So they work with any phone. Question's not about Google Glass. Since I don't really, I'm only telling you things that are already available on the internet. Questions about like college or science? Yeah.
What's your favorite project you built in college?
Oh, that's a really hard question. I don't know. They were all fun. I didn't do any projects I didn't like doing. I don't think I showed a picture of it, but one thing I spent a lot of time on was I built me and a team of people obviously built a solar powered home. So like an entire house, built a house, entirely energy neutral, so it consumed as much power as it created, which is obviously a very large and significant systems level engineering problem. So designing the electrical system for the building to be able to monitor electrical usage and adjust it over time. Control interfaces, you could like control the lights and stuff from your phone, your computer. It's like a very smart house. So that was kind of cool just because it was a big systems engineering problem and I like things with a lot of facets to them. And I got to work with a lot of smart people because that's obviously like a many person project. That's probably one of my favorite things I did. And a lot of colleges have like project teams that will do like large scale design projects like that, whether it's building a race car or a submarine, not like full size submarine, but like autonomous submarine, solar powered cars. Most engineering schools have some kind of program like that. And so I did it through something like that, and I'm very glad I did. I strongly recommend doing something like that. It's a good opportunity to meet lots of smart people and work on something that's pretty exciting. You have time for more questions? No, you got cut it off.
No, you guys got. You
This
can
is
ask
cutting
me
me off.
later. He'll be around a little bit longer.
I'll hang around for a little bit. I can answer other questions. Thanks, guys.
Yeah.